Case Study 1. Hakim planned to buy a house in a few years. To achieve his goal, he decided to deposit part of his income into an investment account that offers 4.1% annual interest, compounded quarterly. After 8 years, his savings has grown to 180,547.26 ringgit. After reviewing his financial progress, Hakim began to explore other options for reaching his housing goal sooner. How much money did Hakim initially invest at the beginning? S equal P 1 plus K per M, 0.041 per 4, that given 0.01025. N equal empty, that given 4 multiply 8, that answer will be 32. For that, 180,547.20 ringgit is equal to P 1 plus 0.041 over 4 square root 32. So the answer is 130,276.86 ringgit. B. Calculate the total interest earned over the 8 years. I is equal to S minus P. 180,547.20 ringgit minus 130,276.86 is equal to 50,270.34 ringgit only.
To find the time need, the compound interest formula is used. The future value equals 250,000 ringgit. The principals equals 130,276 ringgit and 90 cent. The annual interest rate equal 4.1% and the interest is compounded quarterly. The equation become 250,000 equals 130,276 ringgit and 90 cent multiplied by 1.01025 to power of 40. After dividing both sides by 130,276 ringgit and 90 cent, the result equals 1.9189840 equals 1.01025 to the power of 40. Taking logarithm on both sides give 40 equals 63.92. Therefore, the T equals 15.98, which is approximately 16 years.
Hakim want to reach 300,000 ringgit in 5 years with interest compounded quarterly. The present value is 130,276 ringgit and 90 cents. The time period is 5 years, and since the interest is compounded quarterly, there are 4 compounding periods per year. Therefore, the total number of compounding periods is 20. Use the compounded interest formula, which is S equal P times N1 plus K over M raised to the power of MT. After substituting all the value into the formula, we divide both sides to isolate the compounded term. By taking the 20 root, we obtain the quarterly period rate, which is 4.26%. Finally, by multiplying the quarterly rate by 4, we got the nominal annual interest rate, which is 17.04%. For the nominal annual interest rate compounded quarterly is 17.04%.
Assalamualaikum and good day. My name is Zahra Zafiruddin bin Zaharuddin. Today, I will explain case study 2, which involves in annuity and compounded interest. Aman saved 500 ringgit every 3 months for 5 years in his daughter accounts with 4% interest compounded quarterly. Since the savings are made regularly, We use the future value for an annuity formula. The interest rate per period is I equals to 0.044 or 0.01. The total number of payment is N equals to 54 equals to 20. Using the formula S equals to 500 bracket 0.01 the power of 20 minus 1 over 0.01. The total amount saved is 11,009 ringgit and 50 cents. Next, half of this amount is withdrawn, which is 11,009 ringgit and 50 cents divided by 2, which is equals to 5,504 ringgit and 75 cents. This money is invested in ABC's banks at 6% interest compounded monthly for 2 years. Using the compounded interest formula, S equal to 5,504 ringgit and 75 cents, bracket 1 plus 0.06 over 12, the power of 34. The final amount after 2 years is 6,204 ringgit and 73 cents. In conclusion, this case shows how regular savings grow over time and how compounded interest increase the investment value. Thank you.
For case study 2B part 1, Rebecca is buying a new photocopy machine for RM100,000 to finance her purchase. She trades her old photocopy machine for RM20,000 and the balance is financed through a bank. An interest rate of 12% compounded monthly. For the repayment of the bank loan, she must pay RM1,779.56 a month. First, we look at the principal amount is calculated as P equals RM100,000 minus 20 equals RM80,000. Next, the monthly interest rate is determined by dividing the amount interest by 12. That is, I equals 0.12 per 12 month equals 0.01. Since the loan repaid by equal monthly installment, the present value of an annuity formula is used. That is, A equals R in bracket 1 minus in bracket 1 plus I on the power of minus N per I. Substitute the value given into the formula, that is 80,000 per 1,779.56 cents in bracket 1 minus in bracket 1 plus 0.12 per 12 per month on the power of minus N per 0.12 per 12. Arrange the equation, that is 80,000 equals 1,779.56 cents in bracket 1 minus in bracket 1.01 on the power of minus N per 0.01. That is 80,000 per 1,779.56 cents multiplied by 0.01 equals 1 minus 1.01 on the power of minus N. The answer of it is 0.4495 equals 1 minus 1.01 on the power of minus N. We put the log on both sides, that is log 1.01 on the power of minus N equals log 0.5505. So we arrange the equation, that is minus N equals log 0.5505 per log 1.01. So the answer is N equals 6. For B part 2, Rebecca misses her monthly payment for 6 months. Therefore, we need to calculate the total amount she must pay on the 7th month. The monthly payment R is 1,779.56 cents. The monthly interest rate is I, that is 12% per 12 equals 0.01. Since the 6 payment were missed, we use the accumulated value of annuity formula, that is S equal R in bracket 1 plus I close bracket on the power of N minus 1 per I. Substitute the values, that is S equals
1,779.56 in bracket 1.01 on the power of 7 minus 1 per 0.01. The amount payable is Rm 12,836.92 cents. So debitor must pay 12,836.92 cents on the seventh payment to cover the missing installment. For Part 3, debitor intend to settle the loan early immediately after making the 40 monthly payment. The original loan period is 60 months. The remaining payment is N equals 60 minus 40 equals 20 months. We use the outstanding balance formula, that is A equals R in bracket 1 minus in bracket 1 plus I close bracket on the power of minus N per I. Substitute the value, that is A equals 1,779.56 cents in bracket 1 minus 1.01 on the power of minus 20 per 0.01. So the final installment amount is the final settlement amount is Rm 32,113.14 cents. Therefore, the final payment required to settle the loan after making the 40 months is 32,113.40 cents.